some logarithmic and exponential equations would still be hard to solve with the methods we've learned. So we could use our calculator to find approximate solutions using the intersect method. So what we're going to do here, we have e to the 0.45x minus 3.7 equals 4.5x plus 9.1. And we're going to put the left-hand side in y1, and we're going to put the right-hand side in y2. Okay, so remember to do e to the x, we're going to do second and then the ln button. So 0.4x, close the parentheses, there for the exponent, minus 3.7, okay? And then in y2, we're going to put the 4.5x plus 9.1. Okay, and I'm going to hit graph. So this is just our standard window. Okay, now we see there is one solution here. There might be one out further, so I'm actually going to hit zoom fit and see if we just see any that are out further. So there's our exponential equation, and here's our line. And we don't quite have it on the screen yet, but we do see it's going to intersect up here. So let's zoom out one more time. And what we really want is like up over there. So we see we're going to have one intersection over here and one intersection over here. And we need to find both of them, the x coordinates. So we're going to hit second calc intersect 5. Okay, and what we're going to do is we're first going to move it over, the cursor over to where we see this first intersection is kind of happening, and hit enter, enter, enter. Okay, and we see that we have one at x equals negative 2.77. Now we need this other one, so we're going to hit second calc. We want the intersect. And before we hit enter, 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 we're just going to move our cursor over closer to the other one and hit enter, enter, enter. And we'll see that our other one is at x equals 10.18 if we round to 2 decimal places. Okay, let's do one more here. We have log base 6 of x plus log base 6 of x plus 3 equals 3. And this is one we could do by hand, right? We could write this as log base 6 of x times x plus 3 equals 3. And then if we wrote it as an exponential equation, we'd have 6 cubed equals x times x plus 3, which would give us, what's 6 cubed, a big number, 216 equals x squared plus 3x. So then we get 0 equals x squared plus 3x minus 216. And now we would need two factors of 216 that add to 3. Well, if we put in here, just to help us out real quick, 216 divided by x, and go to our table. So we'd have 6 and 36. It looks like we're going to want pretty big numbers so that they're close to each other. 12 and 18, close but no. And it doesn't look like we actually get any factors, so we're not going to be able to easily factor this. We could use the quadratic formula or something like that, but let's go ahead and do this on our calculator. So we're going to put this in y1 and this in y2. Now remember, unless you have a newer version of the calculator, we are going to have to use the change of base rule to put this in our calculator. So y1 here, to do log base 6 of x, we're going to have to do log of x divided by log of 6. And then to do this one, we're going to have to do plus log of x plus 3 divided by log of 6. So log of x divided by log of 6 plus log of x plus 3 divided by log of 6. And then in y2 we're going to put 3. And I'm going to hit zoom 6 just so we go back to the standard window. So there's our logarithmic equation. And there's our other equation, and we see, okay, we're going to intersect it once out here. Probably not too far off the screen, but if I hit zoom fit, let's see what that does for us. And we're still off the screen. So we're going to hit zoom out. And I'm going to move the cursor so that it's up by where we want, because what we want is this intersection point. So I'm going to hit enter so it zooms out. There's my logarithmic equation. There's our line, and now we see where it's intersecting. So we can hit second calc, intersect, hit enter, enter, enter. And we see that our intersection point is x equals 13.27. So that's how we use our calculator in the intersect method to help us solve exponential and logarithmic equations.